My name is Matthew Ferguson. I'm a postdoctoral researcher here in UCC, and we are working on using 3D printing to make electrodes for hydrogen production through water splitting. So our goal is to fabricate electrodes with the highest solar to hydrogen efficiency through the hydrogen evolution reaction, also known as HER. We are using 3D printing to make our complex microlattice electrodes. So more specifically, we're using a 3D printing method called SLA, stereolithography, which is also known as vat polymerization. So this is a highly accurate 3D printing method. It starts with a liquid resin, which is solidified layer by layer by laser light. For our work, the lattices are then coated in different electroactive materials such as nickel, gold or titanium dioxide to determine their viability and effectiveness as water splitting electrodes. The printer we're using can achieve a resolution of 25 micrometers per layer, which allows us to easily print highly complex high surface area electrodes. These type of electrodes are very desirable for water splitting because they allow us much more space for the reactions to take place, hopefully resulting in a higher rate and quantity of hydrogen production for a fixed area, volume and applied potential, or ideally in our case, no applied potential. 3D printing allows us to have complete control of the design and architecture of our complex lattices, and we can easily and quickly prototype several different designs to see which one works best. Though it's ideal for prototyping and for small-scale studies, the high printing times and the high cost as well of the raw materials would be a hindrance for mass production. But 3D printing technology is always advancing, always getting better, so yeah, in the near future it could be far more viable. For the next part of our work, once we've narrowed down the best lattice design, we're going to work together with our research partners in the FreeHydroCells project, and we'll work with them to coat our lattice, whichever one works the best, in the most effective and efficient material for the hydrogen evolution reaction and water splitting. Beyond hydrogen production, 3D printed electrodes have potential uses in energy storage, fuel cells, and even small medical implants. We're excited to explore these possibilities and see where the technology could be used in the near future.